Good afternoon, everyone. I would like to take this chance to welcome you to our lesson today. I don't know where you're watching me from. I don't know where you are. Emmanuel Rabuti, you're asking, uko wapi? And I would like to tell you, Nico area. Where uko wapi, Emmanuel? Good afternoon. Yes. So we shall be proceeding. There are those people that I sent the paper, which is the physics paper, and that's what we shall be discussing today. It is pressure, and the topic is pressure. Pressure is the is it the third or the fourth topic? In Form 1. It's a paper 1 topic, which is love, that will contain pressure. The case is to come next week, but I know it will contain the topic pressure. So it's a topic that is rich in content of physics. That's why I said that today we are going to discuss the topic pressure using a certain paper. I've been using that paper for the last 3 years to prepare my students in pressure. When Emmanuel was asking me if 2 p.m. itafika, hivyo angalia saa yako uone ni saa ngapi. Mine is saying 2 or 3. Emmanuel Jumarakuti. Wachana na it's already 2 p.m. Emmanuel, confirm that you can show that on the screen. The way we inafaa niambie kama maandishi inaonekana kwa ubao. At the same time, confirm that you can see the paper which I've just displayed on the board over there. That's what we are going to discuss today. Pressure, I'm going to give a laydown of pressure so that you can be able to see how pressure looks like. The paper you're seeing on the screen is actually a paper that we are going to discuss today. It is a contest paper, Nyabururu Girls High School. I was going to read the paper and I realized that it contains all the areas required in physics. If we can answer this question one by one, then you will be in a position to answer all any other questions in pressure. Are you together? But basically, allow me to give you the breakdown of pressure so that you can also Emmanuel, you are saying you are only seeing the word pressure. No problem. I think with time you can see what I will be writing on the board. So pressure, I want to split it into very many parts so that each part you can be able to see how it will go about. So number 1, the first concept, you must know how to define pressure and give the SI units. Emmanuel, still you cannot see what I'm writing on the board. Define pressure and give the SI unit. That is the concept number 1. I can ask you whether you know how to define pressure, whether you know the SI unit of pressure. All these we shall check. Number 2, I want you to have some concepts. Pressure in solids. Pressure in solids. Good. Pressure in solids. So pressure in solids is another part that you need to know how to calculate pressure in solids. It's always force over area. Formula if you want to calculate pressure in solids, it's always force over area. That's the concept number 2. I would like you to know pressure in solids. Then number 3, we have pressure in liquids. Pressure in liquids. Yeah, pressure in liquids. You know, a liquid can exert pressure the same way a solid can also exert pressure. So what am I saying here? To calculate pressure in liquids, it is given as rho, G, and H. So we have 2 formulas for calculating pressure. And at some point, the 2 are interdependent on each other. There's a question in that paper of ours that we are going to check on that will require us to combine these 2 formulas. But this pressure is given by force over area in solids, and pressure is rho GH in liquids. So after that, concept number 4, I want you to talk about atmospheric pressure. atmospheric pressure. Atmospheric pressure. Atmospheric pressure. Yeah, you know how atmospheric pressure is measured. I want you also to know how we operate with atmospheric pressure. Define the term atmospheric pressure and state its effects. In our paper still, we are going to check. There's a question that we'll be talking about atmospheric pressure, and I would like you to keep on with it. So, when you talk at can you learn how to concentrate for the next 1 hour 30 minutes? You will be done with the paper. So after learning about atmospheric pressure, I want you to learn about a certain concept in pressure. We call it the Pascal's principle. Pascal's principle. Pascal's principle. Usiandike principle ya principle when wa shule. It's a principle which means Pascal's rule. Pascal's rule. I think now you can see what I've written about Emmanuel. Emmanuel, can you forward the link to your students? Now, after stating Pascal's principle, we give some of the examples of the machines that operate under Pascal's principle and know them. Hydraulic press system. Hydraulic brake system. Then, after looking at that, after looking at the Pascal's principle, we look at the concept number 6, measurement of pressure. Measurement of pressure. How do we measure pressure? What do we use to measure pressure? If I may ask you. Yes. It depends on the kind of pressure you want to measure. If you want to measure atmospheric pressure, we use a mercury barometer. If you want to measure the pressure of a gas in a tube, we use a U-tube manometer. We shall all be checking on this, and I will tell you how it will operate. Then from here, after learning how to measure pressure, it will be fair enough if you talk about applications of pressure. Applications of pressure. Applications of pressure. Now that we have learned pressure in a broad dimension, how do we now apply it? You know, we don't just study something because to study, you know, it's not for fun. We don't study for fun. We study so that we can apply it somewhere. You know, it will make some sense. So, what am I saying? So, let's learn president pale tumalizie pale kwa applications. Where do we apply pressure in the real life? So, can we go to our paper? Yes. The person watching, check for me if you can read for me what I've just shared on the screen. Just check if you are in a position to read it. Yes. Then make a comment. Niambie kama unaiona. You must be seeing it. Make a comment. Niambie you can see my screen that I've just shared. It is for Nyahururu Girls High School. Kuna kitu imeandikwa pale chini. Sijui imeandikwa nini. Can you read something written down there? Somebody is owning physics. Anasema my physics, my A. I don't know what are you saying about physics. Huyu amesema yeye my physics, my A. Ndio unasema nini? My physics, my A. Okay, I think it is very feasible. So let physics be your A. So whatever you have written on the board, can you just write it somewhere so that you can be using them to devise, so that at any given time you ask yourself whether you know how to define pressure and give the signs of pressure in solids, pressure in liquids, atmospheric pressure, Pascal's principle, measurement of pressure. And when we talk about measurement of pressure, I've said it depends on what kind of pressure do you want to measure. Number two, it also depends with the accuracy of pressure you want to measure. And applications, there's so many. Start with the hydraulic brake system itself, hydraulic press system, siphon, force pump, lift pump, and all those. So those are the questions. Know how to explain about such applications. Are we together? Good. So now, I wish we were in a position whereby all of us, I can also hear from you. But now, it's like a monologue because no one is there to talk back to me. Combine, but no problem to the process. If you have any question, you just write it on the comment section. So allow me to clean the board, then we proceed with question number 1. My physics, my A. My physics, my A. So someone is only this and my physics, my A. Now, the first question reads, let me read the first question. A vacuum pump was used to pump out air from the glass tube immersed in liquids as shown in figure 1 below. After some time, the level of the water rose to position X. Mark Y, the corresponding position for the paraffin level. Give reason to your answer. Good. Yeah, so let's look at that. I don't know whether there is need for me to redraw it on the board. But now, look here, we have 2 containers. This way. And when we have these 2 containers, all of them, they have the same pressure. All of them, they have the same pressure. Now, it's gonna liquid up to a certain level. All of them gonna liquid back up. All of them gonna liquid back up. But now, this one is paraffin, and this is water. So they're asking you, show the level of the liquid in each case. So kama ushapewa hapa kwanza umeambiwa imefika hapa for water. What will happen to the level for paraffin? So what is the difference between paraffin and water in this case? What brings about the difference is what we call the density. The 2 of them have different densities. Paraffin having less density. What? Now, because this is having a less density, and so it's having remember all of them are subjected to the same pressure. So rho GH, rho G and H for paraffin, rho and GH for water. So for the G and G, they're the same because that is the force of gravity and gravitational field strength. It is the same. Now, because the density for water is high, it will have to have a shorter height so that it can maintain the same pressure. So, ukisema hivyo the height of water, then for paraffin it must be a little bit higher because its density is lower. So anywhere above E copper, so it will be above X kilogram. Why? Because it has a lower density, so it has to maintain a higher height in order to maintain the same pressure. Good. let's look at question number 2. Kama uko na swali, comment on the comment section. I will work with you. Kuna swali imesema define the term atmospheric pressure. Define the term atmospheric pressure. Ingekuwa leo ungesema atmospheric pressure ni nini? First of all, kumbuka it's a term that comes from the word atmosphere. Pressure, atmosphere. So, what can you say about atmospheric pressure? Let me explain something small kidogo before I define atmospheric pressure. If you go to a higher mountain, maybe wewe ni mtu umezoea ukiishi upande wa chini ya valley. Kama uko chini uko Kerio Valley, then all of a sudden ukapanda basi ukaenda within a very short time umefika Iten, the higher sides of the town, you will no split. You will no split. Why do you have to no split? Because the pressure is not balancing. Umetoka mahali iko a high pressure, umekuja mahali kuna low pressure. So the pressure in the body is not balancing with the pressure outside, and the pressure outside is the atmospheric pressure. Na hiyo ukitoka nayo kwa mountain ukiteremka chini za mara moja, you will feel your ears blocked. Why? Umetoka mahali kuna less atmospheric pressure, umeenda mahali kuna low atmospheric pressure. So how do we define atmospheric pressure? It is the pressure exerted on the Earth's surface by the column of air around it. The pressure exerted on the Earth's surface by the column of air around it. Like we measure atmospheric pressure using mercury barometer. And we can demonstrate atmospheric pressure using crushing gun experiment. So look here. Kama hapa ni mountain na hapa ni valley, hapa iko na low atmospheric pressure, hapa iko na high atmospheric pressure. Why? This one has a very high column of air. Look at this. Na hii ni kidogo. Are you getting me? So I think that's okay, and that's in order. Now we can proceed with the other part of the question. So the question reads, the question, part B of the question. Now, the height of the mercury column in barometer at the base of a mountain is found to be 760 millimeters and 610 millimeters at the top. Determine the height of the mountain if the density of the mercury and the air is 13,600 kilogram per meters cubic, and that of air is 1.25 kilogram per meters cubic respectively. I will explain that. So, so the question says, the mercury barometer at the top of a mountain is 610, and at the bottom of the mountain it is 760. So we have a mountain this way. So the mercury barometer in a guy. So the level of mercury rise above determines the atmospheric pressure. So hapa tumeambiwa ni 750 millimeters of mercury. Na hapa juu tumeambiwa ni gapi? 610 millimeters of mercury. Right together. So that's to determine the height of the mountain. The difference in the pressure is because of the air column here. Now, there are two ways. If you are doing this question for the first time, calculate the pressure at the top of the mountain, calculate the pressure at the bottom of the mountain, then get the difference. After getting the difference, you equate that the difference of pressure here and here, you equate to the rho g h here air, rho g and h of air. We are in that question. I can see we have been given the density of air, and then of course G is 10, then the height of the air column is now the height of the mountain. So what can we say here? So, okay, this is what I'm doing here. But if you're doing this question and you've been doing it and you know how to do it, you simply say 750 minus 610. Ukishapata 760 minus 610, kumbuka ni millimeters, you have to make it meters. 750 minus 610, ile ni 140. Why am I doubting my brain? No, but I think 140. It's the boss as 140 millimeters. You 140. Can we make it meters? Just divide by 1,000. Then it's going to be 0.14. 0.14 times 10 times what? See, this is the height, this is the G. Then because the mercury, there's the mercury in 13,600. I've just applied rho GH here. Should be equal to the rho GH here air. Rho for air is 1.25 from the question times G, which is there, times H that we don't know. So this H is the height of the mountain. I hope you get that. Now take your calculator very fast. Find for me the value of H as we are marking the question. Good. So now, what is there is, allow me to finish the calculation. Allow me to use my calculator from my phone. So at this point, the authority take the responsibility. You will put in a 14 number. You will tell 14 times 106. 14 times 106, but the 1904 times 10. But the of course 19, 0 and 40 to be equal to 12.5 H. So our value of H, I hope you can see it, our value of H is going to be 19,040 divided by 12.5. Then you get 1523.2 meters. So come on, ulipata 1523.2 meters. You deserve to clap for yourself. Yes, because you've gotten it right. We found out the process, and right now you have it right. So that's okay. Let's go to the next question. The next question reads: give a reason why mercury is preferred as a barometric liquid. Give a reason why mercury is preferred as a barometric liquid. Give a reason as to why mercury is preferred as a barometric liquid. Okay, we have many other liquids. We have water, we have milk, we have paraffin, we have kerosene, we have, very many liquids. But we always prefer mercury over any other liquid. I wish kama kuna watu walikuwa wanafollow waandike their answer hapo kwa just why mercury is preferred as a barometric liquid. Because it has a higher or a high density, therefore the column required is shorter. Short. Yes, that's the point. Ukitumia maji, this is how a mercury barometer looks like. If you use water, you will require a tube that is over 10 meters. That is being hectic. But if you use mercury, you will only require 1 meter. Why? Because mercury has a barometric height of around 76 centimeters. So that's less than 100 centimeters, which is less than 1 meter actually. So mercury parameter ikaa hivi, if the liquid is very denser ina rise tu kidogo, lakini ukitumia very less dense liquid ina rise mpaka huko. Yeah, sometimes that's how to switch from one to another, lakini don't worry. Now let's continue with the question. Give a reason why nose bleeding is likely to occur at the top of the mountain. Very simple. At the top of the mountain, why is nose bleeding likely to occur? Because of one reason. At the top of a mountain, there is a low atmospheric pressure. So the blood pressure in the body is higher than the pressure outside the body. And therefore, to balance the pressure, some blood has to be released. And the best place that blood gets leaked out of the body is through the nose. Nose has very weak membranes. I'm not saying you write this, I'm just explaining it. But it can take place for nose and not your mouth. Mostly, nose has very weak membranes. It breaks easily. And actually, if someone nose bleeds, it's a sign that now after that you will be in a good health. So usikuwa na shida. Though kuna watu wako na tabia nyingine ya nose bleed kila siku. Unaamka asubuhi una nose bleed, unaoga na maji baridi una nose bleed. Kuna mwingine akioga na maji warm ana nose bleed. Kuna mwingine akikasirika ana nose bleed. Kuna mwingine akiwa na njaa ana nose bleed. Kuna mwingine akiwa na usingizi ana nose bleed. I don't know wewe una nose bleed hivi. What time? So people nose bleed at high mountain because there's a low atmospheric pressure compared to the pressure of the blood in the body. State the principles of pressure in liquids. Okay, the question is okay. The principle is Pascal's principle. So in short, unaambiwa state Pascal's principle. Pascal's principle ni kama a rule. Don't change the words. Keep the way it is, especially when you ulipewa kwa Kelvin. Yeah. Pressure applied at one part in a liquid is transmitted equally to all other parts of the enclosed or the enlarged liquid. You can use the word enclosed or enlarged liquid. I don't need to write that one, I'm just telling you that the pressure applied at one part in a liquid is transmitted equally to all other parts of the enclosed or the enlarged liquid. You can check on my notes. Those when you talk about WhatsApp group moja, I will send you that note that we shall be using for the discussion. So I think that is very, very well. So you know to state Pascal's principle? Nice. So the next question reads, tumemaliza page 1. So now we can proceed to page 2. Yes, we can proceed to page 2. Page 2 reads, we are marking this paper. So when you have stream, look at page 2. You can see that diagram. I hope it is visible from your side. I'm just going slowly stand at your sana. I'm trying to read from my side, but figure 5 below is a simple diagram. Simple hydraulic machine used to raise a load. Calculate the load force raised at B. Very well. So first of all, which formula do we use here? Now back to me. Which formula do we use here? Let me draw it. So I must write the correct values. So the force applied here the force applied here is 120 newtons, and the force applied here, which is the load, we don't know. The cross-section area here is 0.006 meters square. Nice. And the cross-section area here is somehow big, 0.5 meters square. Now, from Pascal's principle, you must be aware that the pressure at this point is the same as the pressure at this particular point. Are you together? So what can we do? So the pressure here, which is force 1 over area 1, to be equal to force 2, which is the load, over area 2. Now, this one is given by, I hope you can see what I'm writing. Let me see. Come up to 120 over area 1 is 0.006 to be equal to the load, which is F2 load, over 0.5. So our load is a force. Load is like weight, so it's a force. Now, up to this point, we just need to cross multiply. How do we cross multiply? This way. So our load is given by 120 times 0.5 divided by 0.006. So 120 times 0.5 will be 60. 60 divided by, hata hiyo unafanya kwa side yako tuone kama umepata. 60 divided by 0.006. So you get 10,000 newtons. Hapa ni 10,000 newtons. 10,000 newtons. Kama ulipata 10,000, jameni, mbona usijipigie makofi? You are very correct. Yeah, good. So let's proceed to the next question. The next question is, give two properties which make the oil suitable for use in this machine. In this machine. So in simple terms, can we give the properties of oil in hydraulic brake system? Those properties will work out very well here. Right together. So one, oil cannot corrode the parts of the system. This system, oil cannot corrode the parts of this particular system. Oil cannot corrode the parts of this particular system. Yes, that's why we prefer oil over others like water. Number two, oil is highly incompressible. Oil is highly incompressible. I think oil is highly incompressible. Then oil has a low freezing point and a high boiling point. Low freezing point and high melting point. Give me a thumbs up if you are following me. I thought those who are following, can you say hi? Okay, nice. Now let's proceed with the other part of the question. Kuna swali hapo. I hope you can see question 5. Let me see if it is visible from your side. Question 5 reads, in an experiment to demonstrate atmospheric pressure, a plastic bottle is partially filled with hot water and the bottle is then tightly corked. After some time, the bottle starts to get deformed. State the purpose of the hot water. The purpose of the hot water is to remove the air in the container and the bottle. The hot water contains steam that removes the air in the system. Someone to confirm about my audio. Can you hear me very well? Those who are on. Is my audio, can you hear me? That is the point. Yeah, as you are confirming, let me just explain that. If you put water in a container, what will happen is that the hot water contains steam that removes the air out. After it has removed the air outside, now the pressure inside the container is less than the pressure outside. I'm answering part B of the question. Explain why the bottle gets deformed. Because after the air has been removed by the steam from the hot water, the pressure inside becomes less than the pressure outside. And therefore, what happens? What happens? In a poor deformed because the pressure is not balanced. Here it in a crash the container inside. Right together? Higher. Question 6. Okay. Kuna swali hapa question 6. Question 6. Can you let's read together question 6. Let's start with 1 to 3. Given that a container has a cross-sectional area of A and it contains a liquid of height h whose density is P, show that the pressure due to the liquid column is given by H rho G. I'm still waiting for someone to tell me kama mnanisikia vizuri wenye mko online, kwani kutype itakost nini? Usipotype leo utashikwa na polisi jioni. So look here. The question is reading this. The question is reading. Let me clean the board so that we can answer from the same script. Kuna container imekaa hivi. I hope you can see this container. This container has a cross-sectional area A hapa chini, and water, is it water liquid iko na height h. Wameweka liquid mpaka up to a height h. Going together? And tumeambiwa this water this liquid has a density of rho. Its density is simply rho. Show that the pressure due to the liquid. Show that the pressure due to the liquid is given by rho GH. Rho GH. Lakini swali imesema is it rho GH? H rho G. We cannot change. I was just writing intentionally so that I can explain. Kama imesema H rho G. Make sure your final answer is this one. Now, that can find it in how many steps? Let's do it in like 3 steps. Let me see whether you can see what at that point I have to be back to see whether you can see my screen. So now, first of all, I have to calculate the volume. Step number 1. The volume of the liquid is given by AH. That is the volume. You see me cross-sectional times that is the volume. Ukiwa na volume na unataka mass, how do you go about it? Nataka tupate mass hapa. Hii ni our equation number 1. Nataka to calculate mass. How do we get mass when you are volume? So matter density is given by mass over volume. So ukitaka mass, this volume times density. We have the volume AH, so it's going to be AH times the density. But then put the AH and grab. So we have mass. Lakini sasa hii sitaki mass, nataka weight. Ukiwa na mass na unataka weight. Ukiwa na mass na unataka weight. How do you go about? You multiply with G. So unakuwa na A, H, rho, and G. That is the weight. Did I tell you that weight is a force? or force is a weight. You cannot, the two are actually the same. So the two are the same. Now, starting weight sasa tunataka pressure. Pressure is given by force over area. Na nimesema force na weight ni kitu moja. So it's like saying pressure is weight over area, which okay. Now our weight is A H rho G, A H rho and G over nini over A. This is pressure. So let A cancel A. So our pressure is going to be H rho and G. Kama ulifuata hii process yote, can you clap for yourself once? Nice. Question 2. Oh, not question 2. Why am I going to say question 2? Am I in question 2? No. Kumbuka kwa hiyo karatasi ukisoma hapo chini imeandikwa my physics my A. So as we are doing every question here, we are doing it for your A. The figure below shows a long tube filled with water. The open end is then covered with the cardboard and tube inverted. It's observed that the water in the tube does not spill out. By the way, such thing is simfanyenge kwenye nyumbani. Mbona uweke nyumbani? Tafuta container. Don't be a boring guy or boy at home. Fanyanga physics, ambia mzazi. Unajua mimi nafanyanga hii si uchawi. Mwambie hii nayo si uchawi. So if you have a container, kama ile ya chupa ya yogurt, I am quite sure umekunywa yogurt in the last 1 week. I'm telling you guys, boys, unakunywa yogurt kwa nini mwanamke? Yogurt ni ya girls. So wenye ukisikia brother atataka yogurt mwambie aseme kama yeye ni a lady. Sawa, ukiwa na container kujaza maji, or any other liquid unaweka cardboard na ushikilie juu, the cardboard will not fall. Umeandika nini kwanza? The cardboard will not fall. Why? Because there is a high, hapa imejaa maji. But if the water is half or, it will have to fall down. But when it is full, in atmospheric pressure will be holding the paper in place. Imeshikilia. Because huku ndani, it has very, in fact, it is either less or no pressure. You can use the word less or no pressure. So, and there is high atmospheric pressure holding the cardboard in place. This is the cardboard. So I just now nice. Next question. Your page measure, I think in measure we can get to page 3. Page 3, if I'm not wrong. Yes. Now we are in page 3. The first question reads. Now to tell a big logo because remember it's edited to make it to back and forward. So as you can see in that question 8, I hope it is visible from your side. No, I need to move to page 3. Yes. Determine the density of liquid X given that the density of water is 1 gram per centimeter square. Oh, nice. Sini kama ile ya kwanza tu. Ile tulifanya. Now focus on the board. So, ukiwekewa hivi kumpa jamii na mimi sikunywaga jana. So nataka ujue kwamba hii ikiwa water, hii ikwe liquid X. Kwanza mtu mwenye hata before ufanye angalia the height. Hii iko na 30 cm imefika hapa, which is 30 cm. Hii iko hapa, which is kani ndio kubwa, hii ni kubwa, so hii itakuwa somewhere hapa. So hapa ni 25 cm. So kwanza the one with a long height, it will have a lower density. You lazima ujue. Why? Because rho GH at this point is the same as rho GH at this other point. Now, if that is the case, rho GH ya huku ni sawa na rho GH ya huku. Are we given the densities of tumeambiwa ya water ni 1. So rho GH hapa rho, which is 1000 because I'm converting to kilogram per meter square, times G, which is 10, times H, which is 30 centimeters. Don't use centimeters, use meters. To be equivalent to rho ya huku hatujui, times H, which is 0.25, times G, which is 10. So our rho, which is density of liquid X, is going to be, you can multiply yote utapata 3000. 1000 times this inakupea 10,000 times 0.33,000. You divide by, I hope you can see what I'm writing. You divide by this times this, you divide by 2.5. So it's like at just take your calculator in a very simple way. You should have a calculator, say 3000 divided by 2.5. We get density 1200 kilogram per meters cubic. That is the density of liquid X. And because we are given the density of water is 1 gram per centimeter cubic, then we can also give the density of liquid X as 1.2. You simply divide by 1000. I hope we are together in this. Next question reads: explain why water can build with thicker walls at the bottom than at the top. Answer is one here. To withstand the high pressure of the water at the bottom of a tank. To withstand the high pressure of water at the bottom of the tank. Kuna swali sije content diagram vizuri. Question 9b. Everybody can see question 9b. The diagram below shows that follow. State and explain effect on the height towards the bottom of the liquids. Then it means that the height H will increase because pressure increases with depth. If you do na explanation mingi. Yes. So the last question in this page is the one you can see on the board, question 10. Question 10, I think you can see it now, right now. If you can read it for us, well. But yeah, just be getting it. Let me set up something here, then we will proceed. Yes, let me just, as we are about to work on question. Leo nitachukua kidogo tu alafu tufanye swali. we are supposed to determine height h. So the heights are not the same. Let me just draw this kidogo. Hapa ni 120 kg. Mhm. 40 newtons iko pale. So umeambiwa hii height imekuja mpaka hapa. Calculate this height h. Calculate that particular height h. So hapa tutafanya mara mbili. Force over area plus rho gh should be equal to force over area equal to. So force here, because we are told here we have the 40 newtons and the cross-section area here is 25 centimeters square. Yes? Nene. Kwa nini? So sorry for that. I was attending to somebody. So we have here is the 25 centimeters square. So rho gh plus force over area part should be equal to force over area the other part. In a 2 in a 1 1. So rho gh hapa rho which liquid is this? Oh, tumepewa liquid ni 8. You correct this 0.8 grams, so it is 800. So itakuwa 800 kilogram per meters cubic times 10 times h inatujui plus force which is 40 over area which is, you will allow me to work, okay, no, let me just convert 25 centimeters square into meters square. So 25 centimeters square, I will simply divide by 10,000 in the meters square. So it's going to be 0.0025 meters square. Let me confirm. 1, 2, 3, 4. Where? 0.0025 to be equal to force in even 20 kilograms. So to make it force in 1200, I just multiply by 10 over area is 80. So it's going to be 80 divided by 10,000. Itakuwa 0.008. Let me confirm kama niko 1, 2, 3. Where? 0.008. You know, to multiply the 10,000. Yes, so 1, 2, 3. Where? Now that's it. So this one is going to be, let's put it together. It's going to be 8,000 h plus kufanya pamoja na calculator sema 40 divided by, na usipo na haraka, kama uko na haraka hiyo jipe shughuli basi, hizi tutafanya pole pole. 40 divided by 0.0025, 16,000. up and 16,000 to be equal to. Sasa chukua 1200 divided by 0.08. Aya, 1200 divided by 0.008. Napata 150,000. 150,000. Well, ukishapata 150,000, take this and minus huko. 8,000 h equals to, I'm transferring the information by that. It's equals to, first of all, 150 minus 16 got 134,000. It's equals to 134,000. 134,000. Good. Now, 134,000, we can get the value of our h. 134,000 divided by 8,000. Yes, you get 16.25 meters. Yes, so that's the point. What did you get? Yeah. So I think we have followed together up to that particular point. Are we done with the slide? Can we go to the next page? Let me see. Let's begin my coffee. My physics, my day. Let's get to 4. Question 11. We are at question 11 right now. And we will try to move a little bit faster. We are at question 11. Now you can see, let me read the question. If the atmospheric pressure is 750 millimeters of mercury, what is the pressure of the gas in millimeters of mercury? And then what is the pressure of the gas in Newton per kilograms? Now, Newton per kilograms, what is the pressure of the gas in pascals? So that is about it. Now, ukiangalia hiyo diagram, so let me bring back to you. Which diagram? Yes, I think now you have it there, so you can check on it. The YouTube shown below contains mercury of density 13,600 kilogram per meter cubic, and is connected to a laboratory gas. So if the atmospheric pressure is 750 millimeters of mercury, what is the pressure of the gas? Let me draw it on the board so that you can see it. I can hear some noise outside. Speaker kama ni firefighter ama ni gari ya mtu hataki kususu. About can you now check on what I'm doing here? So hapa tumeambiwa ni 45 centimeters. Then we have the gas getting in here. So now the atmospheric pressure is 750 millimeters of mercury. The pressure exerting here is 750 millimeters of mercury. Then ikiwa hivyo, swali ni, if the atmospheric pressure is 750, what is the pressure? So this gas pressure is pushing the liquid to rise to a height of 45 centimeters, and the liquid is mercury. Then on top of that, you're going to mercury is 750 millimeters of mercury atmospheric pressure. So what is the pressure of the gas in millimeters of mercury? First of all, convert this here in millimeters. 450 millimeters of mercury. So now the pressure of the gas in millimeters of mercury is going to be 750 plus 450 millimeters of mercury. Hiyo unapata ngapi? Chukua 50 kwa hata pa 800, so itakuwa 1200 millimeters of mercury. Yeah, so I think that is the point. Now, in Pascals, unaambiwa calculate the pressure of the gas in Pascals. Sasa ukishapata pressure ujui. Sema pressure, Pascals is the same as saying Newton per kilogram. So pressure is going to be rho, G, and H, which is going to be 13,600 times G, which is 10, times H, which is this one now, 1200, but I will divide by 1,000 because I want to get it in meters. So I'm just dividing it by 1,000 and going to put it in meters. 1, 2, 3. 1, 2, 3. So 13,600 times 12. Now when doing these things, and so you have a calculator. 13,600 times 12. 163, 200. 163, 200. For those who did, that is the answer in Newton per kg. Gotcha. Newton per meter square. What am I saying? Newton per meter square. Good. Any question? Kuna mtu akona swali? But we can still proceed. In case hauna hii karatasi na revise, you can WhatsApp us in this number. We will send you the number. 0740 61 90 25. So you simply WhatsApp that particular number now to pay karatasi. Sema tunataka hiyo karatasi ya pressure. We will send it to you. Can we proceed? Of course, yes. Unataka no ndio nipindi fanyika tutakusikiza. Question 12. We are doing question 12. Two immiscible liquids are poured in a container to the levels shown in the diagram below. If the density of the liquids A and B are 1 gram per centimeter cubic and 1.5 grams per centimeter cubic, respectively, find the pressure acting on C, solid C at the bottom of the container. So here you will have to calculate rho GH per mil, simply because we have the first liquid and the other liquid. So we have liquid A and liquid B. So we have to calculate the rho GH for A, then rho GH for B. Then we add the two of them. As simple as that. Back to the diagram. So look at that. Angalia A na angalia B. So make sure you WhatsApp this number to me results for information. So we have liquid to B above. How many guys do is B? Then we have A. We have liquid A here. So pressure, total pressure in Atwanga, pressure is given by rho GH. Now we have for A, then plus rho GH for B. Right together? Yeah, if you can hear me, just wananifuatilia kila hata wataki kusema hai. Watu kuna shida gani kusema hai? Kwanza na A. Rho ya A. Tumetoa pale ni 1, meaning A ni water. And so I would work with 1,000 times G, which is 10, times h ya a ni 0.4. Imeandikwa 40 hapo, lakini na wako na mita ni 0.4 plus rho ya b density ya b ni 1500 times 10 times h yake ni 0.25. Good. So e multiply itakupea 4000 plus 1500 times 10 times 0.25. Hiyo sitaki kuwaste time, wacha nichukue calculator nifanye maneno hapo. Times 10 times 0.25. Sorry, 0.25. Nikapata 3750. Wewe sijui umepata ngapi? Plus 3750. So 3750 plus 4000. 7750 pascals. Ama Newton per meter square. Are you together? So that is the point. Now I want us to again proceed. So basically you have to understand you clap for yourself. Ukijua umefanya kazi nzuri unajipigia makofi. Sawa sawa. Kuna swali mzuri hapa inasema a small nail may pass an inflated tire and remain there without pressure, reducing in the tire. Explain the observation. Now, let me look at. When you explain this thing, it's if you have a ball, like let's say this container, you pass a nail. Now, the ball is made up of elastic material that will grip onto the nail without allowing air out of the ball. That's why it remains inflated. Zamani tukichezanga volleyball alafu mtu aspike hiyo mpira na nguvu yote, hiyo mpira iende kwa fence, unaitoa hiyo mpira pole pole, na ukipata iko na sindano, usitoe sindano, chukua na kata hiyo sindano ibaki hapo. Why? The ball is elastic, so it will grip on the sindano without allowing air out. The same applies here. Good. Still two factors affecting. I don't know. Can you get that question? Still two factors affecting pressure in liquids: density and depth. In case you ask the third one, say atmospheric, force of gravity, gravitational field of the place, but depth and density of the liquid. Don't write the depth and height. No. Height ni kwenda juu, maybe ni maji kwa pipe ama kwa container, lakini kama ni kwenda chini ya dam, I mean somewhere that we talk of depth. So use the word depth. If you use height, it will be marked based on the masses of the examiner. Use the depth. Then also operate with, say, the other point talk of density of the liquid. Like because of that too, ongeza gravitational field strength. If they ask 2, gravitational field strength is not the answer. If they ask 3, it is the answer. It's one of the answers. Yes. Are you together? Now, there is this question 14. The figure below shows a liquid in a paint. Suggest why paint manufacturers prefer the shape shown to other shapes. Are you seeing that container there? Okay, now see what I'm drawing on the board. We have this container, then we have this. The explanation you are supposed to do here is making into consider that these are equal parts. So if the vein goes expanding outwards, it will take a shorter height for a given volume of water. The same water, if I transfer this water to this container, it will have a longer height. So why do manufacturers prefer this kind of a pail than this? Let me give you the reason. The reason is one. Because it will carry a higher or a bigger capacity of the liquid without increasing the pressure. This pressure will not damage the bottom of the container or the flow in which the container is placed on. Did you hear me? That is the point. My physics, my A. Let's go to question 15. In a braking system, I think you can see that in a braking system, why is the master piston made smaller than the slave piston? Do you have the diagram of brake system with you? For a serious student, I know when you are advising this, who cannot not tell pressure. So we are saying, in a braking system, why is the master piston made smaller than the slave piston? Making it smaller ensures that it has a less area of contact and therefore create a higher pressure. So it's made smaller to generate a higher pressure. I am asking how. Pressure is given by force over area. Area is the denominator. If you make area smaller, you are increasing the pressure. Hapo lazima tuelewane na hesabu vizuri. Question 16. We are this is our second last page actually. Question 16. Explain why when the piston is pulled upward, valve 1 opens and valve 2 closes. Look at that diagram. I hope you are seeing it. The figure below shows a force pump. Outlet pipe, chamber X, valve 2, chamber Y, piston, then we have valve 1, and then we have the well and the piston up. So the question is, explain why when the piston is pulled upwards. Which piston? Yes, when it is pulled upwards, valve 2 has to close and valve 1 has to open. When it is pulled upwards, listen and concentrate on that particular diagram. When the piston is pulled upwards, the chamber Y, the volume of chamber Y increases, making the water from the well to push valve 1 upwards, and therefore it opens. So that's how valve 1 opens, because when the piston is pushed upwards, yes, the water from the well pushes valve 1 to occupy the less pressure in chamber Y. Now, that's how valve 1 opens. At the same time, the water, can you look at that distance between valve 2 and towards chamber Y? When water is getting upwards in chamber Y, when the water is getting to chamber Y from the well, of course it's not affecting valve, it's not affecting chamber X. So the water below valve 2 also will have to move towards chamber Y, because that is where we have less pressure. And in that case, valve 2 closes, because there is no water getting to valve 2. It's actually getting away from valve 2. That's why it closes. Roman 2. The question reads, explain how continuous flow of water is maintained in the pump. Explain how continuous flow of water is maintained in the pump. Well, I will give you one thing. Port downstroke and upstroke pushes the water out. Port downstroke and upstroke pushes the water out. That's why it does not depend. It does not depend on what? On one stroke. Both the upstroke and downstroke makes the water to flow. Therefore, it gives a continuous flow of water. State one advantage of force pump over lift pump. First of all, do you have the diagrams of force pump and lift pump with your notes? Because it's very necessary. You must have them. So they're asking, the question is, state one advantage of what? Force pump over a lift pump. Take your pen and write it somewhere there. The advantage of the force pump over the advantage of force pump over lift pump. It enables continuous flow of water. That is the one advantage. Number two, the height to which the water is raised do not or does not depend with the atmospheric pressure. Yeah, those are the two advantages. Yeah. We're okay. We can now proceed from where we were. Kuna swali kwa hapo question 17. Taka tuharakishe kidogo. Our time is moving so fast. A block of glass of density 2.5 grams per centimeter cubic has a dimensions of 8 by 10 by 15 centimeters. It is placed on one of its faces on the horizontal surface. Calculate the weight of the block. Let's do it very fast. I realized my time is not on my side and we have to finish this paper. The density tumepewa ni ngapi? 2.5 grams per centimeters cubic. Dimensions, which is like the volume, 8 by 15 by 10. So they're asking you now, okay, this one is the volume actually. So they're asking you the weight. So density is given by mass over the volume. So mass is given by volume times the density. 8 times 15 is 120. 120 times 10, 1200. 1200 times the 2.5, the density. Unapata ngapi? Okay. 1200 times 2.5. Napata 3,000. 3,000. Hiyo ni volume. No. Hiyo ni mass. But ni grams. Make it kilogram inakuwa 3 kilogram. But from the question, it doesn't really ask about the kilogram. No, it does ask about the weight. So multiply by 10. Napata 30 newtons. So question 17.8 must have 30 newtons. The least pressure you can exert on the floor. Angalia, the least pressure, I would use the maximum area, 15 times 10. Yes. So pressure is given by force or weight, which is 30 over the or force over area, 15 times 10. When you get it, 15 times 10, 150. Lakini lazima kumbuka hiyo ni centimeter square. So naenda hapa kando kidogo niseme 150 centimeter square divided by 10,000. 1 unit. We will have hii ingine ikisha hapo. So just a minute, let me change something. Well, we can proceed. I think with the camera is quite patient, but no problem. Let's proceed. So, where were we even? Sorry for that. I think that was just a small interruption from camera battery relation. So, 15 divided by 10, what divided by 10,000? Divided by 10,000. So we have 0.0. 0.015. So we are going to have 30 divided by 0.015. So we have 2,000. The pressure is going to be 2,000 pascals. Yes, pascals. Yes, so the last question was the page. Let me see first of all if there is any question on this side. Wait. Sawa. The last question on this page, we get page 6. A piston whose diameter is 1.4 meters is pushed into a cylinder containing a fluid. If the pressure produced in the cylinder is 400,000 pascals, calculate the force applied on the piston. Well, so I think it's feasible. I want us to work on the question 18. I think all of us will get to question 18. We are saying that a piston whose diameter is for 1.4 meters is pushed into a cylinder containing a piece of fluid. If the pressure produced in the cylinder is calculated force. So the formula we use here is pressure is given by force over area. That's the first thing. You know the formula we will use. Pressure is given by force over the area. Force over the area. Then number 2. Do we have force? It is the one we are looking for. Do we have pressure? Yes. Do we have area? We don't have, but we can get the area. Because you have the diameter as 1.4 meters, so the area is, radius is 0.7 meters. So the area is pi r squared. So the cross-section area is given by pi, which is 22 over 7 times the r squared, which is 0.7 square. The area is given by, we can get it easily, 0.7 times 0.7 times 22. You get that one divided by 7. So we have as 1.54. So that is the area we will use, 1.54. So if you want, from this formula, if you want to get the force is going to be area times pressure is going to be 1.54 times pressure, which is from the question 400,000. The minimum of the multiplication, 400,000. We will say 2 times, so it's the same thing. So 1.5 times. Remember, this one when you 4 times 10 power raised 5. So you'll be 4 and 0 stand. 1, 2, 3, 4, 5. So we will have 616 newtons. 616,000 newtons. That is the answer to that particular question. Ukona swali? Do you have a question? Okay, so nobody with a question, we can proceed. So, well, let's get to our next page, which is also our last page. So, explain why the rubber sucker sticks on the clean surface. And then I explained first, was the inner, why to me 1 minute. My friend that makes my name. If this is a flat surface, then you have your rubber sucker imekaa hivi. If you press it, remember you are removing all the air outside. All the air is being removed outside. What will happen is this: the pressure inside will be less than the pressure outside. And therefore, the high atmospheric pressure will be pressing the rubber sucker onto the flat surface. So as you are trying to remove the rubber sucker, you are trying to overcome the atmospheric pressure. That's why it's very difficult. It will stick to. Question 20. It shows a siphon being used to empty water from a large tank into a low-lying container using the tubing. Explain why the tube must be filled with water before the emptying process starts. It has to be filled with water before the emptying process starts to provide continuity or to give continuity of the flow of water. Actually, the force here is cohesive force. The force used in siphonning is cohesive because after we fill with water, as the water now moves continually, one particle pulls the next particle. One particle of water pulls the next or attracts the next particle of water, and that process happens all through cohesive force. But the answer is to provide continuous flow of water through cohesive force. Question. After the tank begins to empty, the lower end is momentarily blocked by placing a finger at the D. You can see where D is good. Determine the pressure difference between points A and B. Pressure difference is 7 meters. Okay, 7.5 meters as the height. The density is 1,000, and the atmosphere. And what about our G? We will use 10. It is simply rho GH. You stack it for any final together. Same even. Because the height difference is 7.5. The formula used is rho GH. Because it is rho GH, rho density is this water is 1,000. G is 10. H is 7.5. It is operating outside atmospheric pressure. Atmospheric pressure by SID. So 7.5 times 10 times 1,000. 7.5 times 10 units 75 times 1,000, 75,000 pascals a Newton per meter square. Right together?
Yes.
And remember the pressure experienced by the finger at the D. It's the same pressure. It needs no calculation. It's just the same thing. Yes. We are in our last question, which doesn't need any calculation, so I will just explain it very fast. Alafu tumalizane na hizi maneno. We will check on that. So the question reads, name the part labeled X. Name the part labeled X. It is known as Torricellian vacuum. Torricellian vacuum. State and explain the effect on the height h when the barometer was taken to a point on top of the mountain. Here at the top of the mountain, you are lowering the atmospheric pressure. What will happen to the height h? It will decrease. Decrease. It will decrease. Explain the test that will be made to find out whether such a barometer has any gas in the space above the mercury. If this is the tube, that is the tube containing the mercury, you tilt this way. After tilting, you can either make the following observation. That space can be filled with mercury or not. If the mercury fills it, then it has no gas and it is okay to be used. If it doesn't fill, then it has a gas and that barometer is faulty. That was our last question. I hope you enjoyed the lesson. That was the paper I assigned to some students to do them. I'm sending another paper that will be done tomorrow in the afternoon. Then every day from 2 to 4, I'm saying this. Keep following our programs. We alternate physics with chemistry every day. Yes. So have a nice session. And I'm glad you have followed me for all this time. If you have not subscribed to our channel, please do so. For receive love from Ambassador Foundation. Thank you so much.